Good morning. In this lecture video, I'm going to explain addressing mode of Module 2. Module 2 is 8051 instruction set. So first we'll discuss addressing modes and then we'll discuss instruction set. So addressing modes means there are different ways of specifying the address of an operand. It's called as addressing modes. That means to say data could be in a register or it could be in a memory location or it can be provided as an immediate value. So that means various ways of accessing an operand or data. Operand in the sense the data on which operation taking place are called addressing modes. Okay. So 8051 provides 5 distinct addressing modes. They are immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and indexed addressing mode. So we'll see one by one. In immediate addressing mode, source operand is constant and specified as a part of an instruction. So when the instruction assembled, operand comes immediately after the opcode. Hence the name immediate addressing mode. Why the name immediate addressing mode? Data comes immediately after the operand when it is assembled. Okay. And that immediate data must be preceded by the pound sign, that is hash symbol. Let's see the examples. These are the example. Move a comma hash 20h. Hash 20h means it's a number. Okay, 20h will be copied to the register A, and we can use with any other instructions based on the instruction format. Add a comma hash 45. The number 45 will be added to the content of A, and the content of the result will be stored in A. Move dptr comma hash 1267 means since a DPTR is a 16-bit register, we can load 16-bit data into a DPTR. Okay, so the number 1267 will be copied to the DPTR. So the advantages of this addressing mode means used to load information to any register including a DPTR, and the disadvantage is immediate data occupies a memory location in the program. So it is about immediate addressing mode. So remember, in the immediate addressing mode, data is specified as a part of an instruction that should be preceded with the pound sign. Next we'll see register addressing mode. So as the name tells, register addressing mode, operands are present in registers. Operands means the data on which operation taking place now. So that is present in registers. And here one condition is there, both source and destination register must match in size. Here certain register names may be used as a part of the instruction, or for other registers we can use addresses. Okay, other register may be addressed by using a direct addressing mode. And here data can be moved between accumulator and any register Rn, where n is 0 to 7. It can be 0, R0, R1 up to R7. Data can be moved between accumulator and a general purpose register Rn. But movement between the general purpose register, that is Rn, is not allowed. Let's see an example. See, move a comma R1. Content of R1 will be copied to a register, and here with R instruction, so content of R1 is added to content of A, and the result will be stored in A. And here see, we specified the register by address. See, the destination 0F0 is the address of B registers, comma R2 means content of R2 will be copied to B register. And move a comma DPTR, it is invalid. It is invalid because the destination is A, correct? The source is DPTR. DPTR is a 16-bit register, but A is a 8-bit register. 16-bit data cannot be copied to 8-bit location. That is why one condition is specified, both source and destination register must match in size. And again, it is invalid. Move R3 comma R2 is invalid because condition is specified. Movement between the registers Rn is not allowed. Not allowed. And advantage of this addressing mode is Instruction have only one byte. I mean, all these instruction except this be specified as an address. No, that is why it is. Yeah, it is also have one opcode, one byte opcode. Instruction have only one byte opcode, and the disadvantage is number of registers are limited. Only few registers are the AP, R0 to R7. Only few registers are there. Next, we'll see direct addressing mode. As the name tells, address of a data is known and that is specified as a part of an instruction. Data is in RAM location and whose address is known and that address is given as a part of an instruction. Let's say example, move R0, 40h means content. See, if it is preceded with hash, it becomes a data. Now it is an address. Content of the location 40h is copied to the R0 register. And again, this address can be a source or can be a destination. In the first instruction, it is a source address. In second instruction, it can be a destination address. So, content of accumulator A register is copied to the location 50h. And move 90h, comma hash A5h. I mean, this is a number because it is preceded with a hash symbol. So, this number is copied to the location 90h. And it can be used with the addition instruction also. Content of the location 67h is added to the content of A and result will be stored in A. Advantage is all 128 bytes of internal RAM can be accessed, addressed, and again address is 1 byte long. So disadvantage, instruction have two opcode bytes. I mean, one byte is opcode, another byte is address, another byte is address. And again this instruction you will have three opcode. One is opcode, another one is memory address, another one is immediate number. 3 byte opcodes. Okay, this is the disadvantage. And indirect addressing. Again here also it's also for memory. For memory operand. So it uses register to hold the address of required data. As the name tells, indirect addressing. Address is specified indirectly. Address is specified indirectly. That means address of an operand is stored in a register. So only users register to hold the actual address of required data, and that register acts as a pointer. So it is also called as a register indirect addressing mode, and that register is specified as a part of an instruction. So for internal data, that means within a CPU, register R0 and R1 is used as a pointer. Only two registers are used as a pointer if for internal data. And for external data, that means outside the CPU, that means external memory, register DPTR is used as a pointer. And that pointer register must be prefixed with the at symbol. See, these are the example. Move A comma at R0. So at R0 is source. That means content of the address which is in R0 is copied to the register A. Whereas content of the address which is pointed by R0 is copied to the accumulator. And so here that indirect address is specified as a destination. Move at R1, A. So content of accumulator is copied to the location pointed by R1. And see, so destination is 45 direct address. Source is indirect address. So content of the location pointed by R0 is copied to the location 45h. And say move at R1, 60h means destination is indirect address at R1 and source is 60h. So content of the location 60h is copied to the location pointed by R1. And similarly, the immediate number is copied to the location pointed by R1. And it is for external memory. Move X. X indicates external memory. Content of the external memory pointed by DPTR is copied to the register A. Again, that indirect the external address can be a destination. It means content of A is copied to the location external memory pointed by DPTR. So these are the examples of indirect addressing. And here advantages is this indirect addressing mode is useful when we access successive memory location. Successive memory location can be easily accessed. And the disadvantage is limited pointer register, that is only R0, R1 and DPTR. Okay. And indexed addressing mode. So in this indexed addressing mode is used to access program ROM, used to access program read-only memory. That means data may be burned into program RAM permanently for repeated use, usually standard lookup tables. So to access those lookup table, we use indexed addressing. So here content of A is used as an index value along with the DPTR program code. That means content of A is added to the pointer and gets the address of actual data. So and that data will be placed in a A. So that old data which was index value stored, no, that is overwrite. And these are the examples. Move C. C stands for code memory. Move C means code memory, or program memory is also called as code memory. So copy the content of ROM address determined by adding content of A and DPTR to A register. So the A register value is overwrite. Or else we can use with the program pointer, that is move C A comma at A plus DPTR. Copy the content of a ROM address determined by adding A and program pointer to accumulate. So this is about addressing modes of 8051. I'll continue in the next video. Thank you.